Hey everyone, welcome to today's session on Introduction to Data Science. Let me start with the benefit for learning data science skill for you, even if you are a student or working professional. So if you are a student, you can learn data science skill and start your career in most demanding job requirement. You can get the real-time project experience. We also provide the experience letter which will be helpful for your corporate career to start. You can complete your final year project with us in data science and other emerging technology. We will provide you the mentorship for your project to complete end to end for your final year. If you are working professional, how data science will benefit you, right? By learning this technology, you can make data driven decision which will be benefit for your organization and career growth. You can upgrade your skill to be competitive in the market. So are you interested in data science program? If yes, I'll just brief you what all the program we have in our data science course. We provide you the detailed introduction about data science, data mining techniques, Python for data science, data structure, computer theory, maths, statistics, artificial intelligence, machine learning, deep learning, NLP, big data, data stream processing, and data visualization. So these are the overall set of subjects which we are going to cover as part of our full course data science program. We do have free lab sessions. We provide the real-time industry project experience. Also, we have recruitment assistance for freshers or fresh graduates who wanted to start their journey in data science program. Last but not the least, we have some promotional offer going on for the student enrolling for our program. Early bird registration up to 50 students for every batch, referral discount, and buddies registration. So if you refer, you will get the discount in your course, and if you enroll with your friend in a group of 3-4, you will get the additional discount in your fees. So I hope now you have understood what all subject we are going to cover in our data science program, the promotional offer and the structure. Like we have free lab session, theory class, real-time project experience, and recruitment assistance, right? Also the benefit for you to learn the data science. Now let us understand what all thing we provide in our data science course. So I have already explain you the subjects which we are covering in data science program. So here we are going to understand the syllabus which we have created by combination of different subjects for 12 month, 8 month, 4 month and 3 months of program, right? This is weekend online class where we are covering theory class along with the lab exercise and real-time project experience. You will be getting the recorded video as well. We also provide recruitment assistance for fresh graduates and the fresher who wanted to start their journey in data science career. We have 100 plus hours of training lecture for data science. This program has customized pricing and time module, so you can choose as per your time and the price, right? So we have different subject and combination of different subjects in a course so that you can select as per your wish and enroll for the suitable course for you. We provide experience certificate for course and the internship which will be helpful for fresh graduates to start their career in data science. This is all about the full course of 12, 8 and 4 month syllabus. Second, we have webinars. These webinars are a short videos or the training which we create every week on different topic by implementing different use cases in the industries. So we release every week different webinars on the technology related topics which we will implement some business cases or the real-time project as per the industries, right? So you can enroll for those webinar every week and learn new things in your webinar, right? So basically we cover a subject along with some implementation of that subject with various industries use cases, right? So we release every week's different topic and the implementation of that subject in terms of solving the problem or the use cases into different industries, right? So this is what our program about data science course. If you are okay, you can go and fill this form and enroll yourself. If you have any query, you can contact to our account team by clicking here or by going to this WhatsApp messenger. We also have our social sites mentioned here. You can go and do follow us on the LinkedIn, Facebook and Instagram. So in today's lecture, what all topic we are going to discuss. We are going to discuss about introduction about the data science, multiple disciplines, use cases of data science, various application of data science, types of data analytics, what all skills are required to become a data scientist. Also, we will learn about the tools used in data science. We will look into the various processes in data science along with the data science life cycle and the data science team and roles within the team of the data science, right? So hope you have understood what all we are going to learn as part of today's session. Let's start with introduction. So what is data science? Data science is basically a study of data, right? So in today's digital era we create lot of data every day. Data is getting created by numerous ways, like when you post something on social media, it's a data. When you click something on the website, it's a data. When you fill some form, it is a data. When you call someone, it is a data. So every day, in and out, we create tons and tons of data, right? So basically the data science is study the data which is being created every day. In layman term, it is only the study and research on the data which is being created on day-to-day basis. So data science is an art of uncovering insights, right? So whatever data you create has some insights behind it, right, or trend behind it. So basically what data scientist does, they uncover the insights and trend that are hiding behind the data which is getting generated by various channels. Data science is a process of using data to understand different things. Data science help to translate data into stories, right? And the storytelling help you in uncovering the insights of data. The insights help in making decision or strategic choices. So basically what we do, we take a data, analyze the trend or the insight behind that data, which will help us to make a decision which is good for business and a strategic choices to take a better decision for your business benefit, right? So this is basically an introduction about a data science. So where it is being used, how we are utilizing the data to uncover the insights behind it and trend behind it, and based on those stories we take right strategic choices and make a right decision for your business. So data science skills are in demand. So we have use demand in data science sector because the skill what we require to do a data science research and analysis is having very low supply, right? So demands for data scientist is high while the supply is very low. As per the US Bureau of Data Statistics, the field is expected to see strong growth and the number of jobs will increase by around 28% by 2026, which means that overall around 11.5 million new data science job will be created across the globe, right? So demand is high, however supply is very low. So it is a very good time for you to go into this field. Be whatever your current job or the study, you can participate in different ways, either by technically or by business knowledge, by any terms. Whatever business you are doing today or the job you are doing today or study you are doing today, you can utilize your data science skill to optimize doing your current way of doing business or job and transform it to next level, right? So data science is not only for the technical guys, it is for business guy, it is for marketing guy. Whatever job you are in, data science skill will be useful for you to understand and take a strategic decision, create a right business model for your business, or obviously for a student it's very good career to start because the demand is very high and supply is very low. These are the some statistics which we can see from a top multinational companies hiring for data science with what pay scale. I took this data from some website where it is mentioned. So Meta hiring data science for $160,000 per annum. Likewise, the others MNC company are also hiring more than 150 or $40,000 per annum, right? So this is by comparing multiple salary. They have given this statistic. So I have showcases this slide so that the fresh graduates will understand the demand and scope of being a data science in the different industry, how it is good to start their career in data science field. Now let us understand the various use cases of data science in different companies, right? So I took some sample like Facebook, Amazon, Uber, Bank of America, Airbnb, Spotify. All are in different industries, right? Social marketing, e-commerce, online cap, banking, and music. So in various industry, how data science is being utilized, some sample use cases has been mentioned here. You can see social analytic improving e-commerce experience for Amazon. Facebook uses data science for social analytics. Amazon uses data science for improving e-commerce experience. Uber uses data science for optimizing rides. Bank of America uses data science for increasing customer experience. Airbnb uses data science for better or improving search. Spotify uses data science for music recommendation to the end user, right? So these all different industries use cases are being implemented with the help of data science technology. Here we have illustrated different applications of data science industry wise. For example, e-commerce, right? Identifying consumer, recommending product, analyzing reviews are the basic applications being utilized in various e-commerce giant. In manufacturing industry, we can use data science for predicting potential problem, monitoring systems, automating manufacturing units, maintenance scheduling, anomaly detection. In banking, we are using data science for fraud detection, credit card modeling, customer lifetime value. In healthcare, we use data science for medical image analysis, drug discovery, bioinformatics, and virtual assistant. For transport industry, we use data science technology for implementing self-driving car, enhanced driving experience, car monitoring system, enhancing the safety of passengers by utilizing machine learning and artificial intelligence. In finance, we use data science for customer segmentation, strategic decision making, algorithmic trading, and risk analysis. Here are some applications for data science industry wise. In marketing, we use data science for cross-selling, upselling, and predicting lifetime value of customer. In social media, we use data science for sentiment analysis, digital marketing. In automation industry, we use data science for self-driving car and politeness, aircraft, drones. Credit and insurance industry uses data science for claim prediction, fraud and risk detection. In sales, we use data science for discount offering and demand forecasting. By using machine learning model, you can forecast the upcoming demand. In healthcare industry, we use data science for disease prediction and medication effectiveness. So basically, we use data science technology to predict disease and provide the medication accordingly. In travel industry, we use data science for dynamic pricing, predicting flight delay, right? So let us understand what all are the type of data analytics, right? So as we have seen, we are utilizing various data science technique to create applications in different industries, right? So we use various models, right? We create various model to use in different industry for predicting or describing something about the data or giving some prescription about the data, right? So basically the data analytics are of four types. First, where we predict based on data available with us. Second, we provide prescription for our business case based on data available with us. Third type is about diagnostic. Now let us understand the another type is descriptive analytics. So in descriptive analytics, basically we describe based on the data available, right? Like in other types, what we do, we provide either prediction, prescription, or diagnostic on the data available. Here we describe the data, whatever data is available, we describe, we visualize that data so that some important decision can be made, right? Let's go ahead one by one and understand each type little in detail. Predictive analytics. Predictive analytics may be the most commonly used category of data analytics. Businesses use predictive analytics to identify trend, right, correlations and causation. The category can be further broken into predictive modeling and statistical modeling. However, it is important to know that both predictive modeling and statistical modeling go hand in hand. For example, an advertising campaign for t-shirt on Facebook could apply predictive analytics to determine how closely conversion rate correlates with target audience, geography area, income bracket, and interests. From there, predictive modeling could be used to analyze the statistic for two or more target audience and provide possible revenue value for each demographic, right? So first we will predict based on some important parameter like area, income bracket, and interest. Then we do statistical modeling by comparing the prediction on the same parameter for two different geography area, right? So predictive analytics is basically identifying the trends, correlation, and causation, where we do predictive modeling and statistical modeling. Both go together, as we have seen in this. Second type of analytics is prescriptive analytics. Prescriptive analytics is where artificial intelligence and big data combine to predict outcome and identify what action to take. This category of analytics can further broken into optimization and random testing. Using advancement of machine learning, prescriptive analytics can help answer the questions such as what if we try this, what if we try this and that, like that. Also, what is the best action for us to choose, right? You can test the correct variables and even suggest the new variable that offer a higher chance of generating positive outcome. So basically what we do in prescriptive analytics, we use a various methods in artificial intelligence and a big data, which will help to predict the outcomes and identify the action to take, right? Means it will provide the prediction, along with that some prescriptions also will be given, right? What is the best action to be chosen, or what if we try this, right? Some prescription will be provided. There are two type of prescriptive analytics: optimization, where we will get the optimum value of prediction with the different data set or data attribute available with us. Second is the random testing. We will just figure or take a random variable and see the behavior of outcome, right? Third type of data analytics, as we discuss, is diagnostic analytics. Here what we do, based on the available data information, we try to diagnose the data and identify some useful information from that data, right? While not as exciting as predicting the future, analyzing data from the past can serve the important purpose in guiding your business. Diagnostic analytics is a process of examining the data to understand cause and event, why something has happened. Techniques such as drill down, data discovery, data mining, and correlations are often employed. Diagnostic data analytics help to answer why something occurred. Like the other category 2 is broken into more specific category. For example, discover and alert, query and drill down. So in diagnostic analytics there are two types: discover and alert, query and drill down, right? So query and drill down are used to get more detail from a report. For example, sales that close significantly fewer deal more a month. A drill down could show fewer work day due to 2-week vacation, right? So for a query we will get an answer, we'll drill down it further, and that way we'll try to diagnostic the data. On the other hand, discover and alert notify a potential issue before it occurs, right? So if something based on data analysis or diagnosing the data, if we see something is going to be very potential issue for us, we will highlight it upfront, right? So for example, an alert about lower amount of staff hours which could result in decrease in closed deal. You can also use diagnostic data analytics to discover information such as most qualified candidate for positive at your for a new position at your company. Last type of data analytics is descriptive data analytics. In descriptive data analytics, what we do, we try to describe data information to business user so that they can take right decision. Descriptive data analytics are backbone of the reporting. It's impossible to have business intelligence tool and dashboard without it. It addresses the basic questions of how many, when, where, what. Once again, descriptive analytics can be further separated into two categories: ad hoc reporting and canned reports. A canned report is the one that has been designed previously and contain information around the given subject. As an example of this, monthly reports sent by your ad agency or ad team that detail performance matrices on your latest ad. On the other hand, ad hoc reporting are designed by you and usually aren't scheduled, right? So canned reports are scheduled report which is being generated at a certain interval which is decided by business to see how business is going, right? Ad hoc reports are something which is being created on ad hoc basis as per the need. They are generated when there is a need to answer a specific business question. These reports are useful for obtaining more in-depth information about a specific query. An ad hoc report could focus on your corporate social media profile, examining the type of people who liked your page and other industry page, as well as the other engagement with demographic information. So basically, this type of ad hoc report you won't need to view second time unless there is a major change to your audience. Data science multiple disciplines. So what all are different disciplines in the data science? As you see in the diagram, data science is subset of all these domains. So it requires maths, statistics, it requires research knowledge, it requires business domain knowledge, it requires machine learning, it requires computer science and information technology related knowledge, software development skills, right? So data science is subset of all these domains and skill. So the best thing is here to know whether you are a programmer or a research guy or a maths and statistics skilled person or even a business domain expert. You can participate in your organization data science journey, right? So we can conclude here, data science is not only for the programmer, or it is not only require a technical skill. A data science team require a multiple skill person who knows mathematics, who knows statistics, who is great in research, who has better business domain knowledge, and obviously the programming, machine learning and software development skills, right? So if you are a part of any of this skill or domain, you can participate in your organization data science journey. Skill set of data scientists. Basically, data scientists require a technical skill, qualitative skill, communicative skill. He should be curious about the information, he should be creative and skeptical, right? So these are the basic behavior and skill which is required by data science. All are not mandatory, but combination of these skills should be there in a data scientist. Tools in data science. So in data science we use different programming languages and the tools to implement different type of model which create our life easy, because there are some already created packages and library which we can utilize directly rather than creating a big low level programming to create our model. On high level we use Python and R as a programming language, SAS, Julia, Weka, Tableau for reporting, Hadoop for big data related technology, SQL and Scala. We will be learning each of these in detail in our full course of data science. Next is algorithm being used in data science. So as we have seen, data analytics can be of different type: prescriptive, predictive, diagnostic and descriptive, right? So to implement those type of data analysis, we use different algorithms to create our model and predict or prescribe based on the data available, or describe, right? So these models are, or algorithm what we use to create models are: logistic regression, linear regression, a priori technique, decision tree, ANN, which is for neural network, SVM, support vector machine, PCA, principal component analysis, k-mean clustering for clustering technique, right? So these are the basic algorithm which we use in data science to create a model for our prescription, prediction, or description of the data or diagnosis of the data. Now let us see how we can create model by learning data. So there are two type of data science model. It can be supervised or it can be unsupervised. Supervised learning, as the name indicate, has a presence of supervisor as a teacher. Basically, supervised learning is when we teach or train the machine using data that is labeled, right? So we will train our model with the help of historic data which is labeled in output category, right? Which means some data is already tagged with the correct answer. After that, machine is provided with the new set of example. So the supervised learning algorithm analyze the training data set of training example, and produce the correct outcome from the labeled data, right? So output is already labeled, and we train our model with historic data for the output variable. As soon as the new input data variable will come, our model will analyze the historic labeling of data, or based on that it creates a outcome variable. Supervised learning is then classified into two category of algorithm: classification and regression. A classification problem is when output variable is category such as red or blue, disease or no disease, right? So we will have some data which is already distinguished between these two, having disease or not, right? So any new data will come, we have to classify it into either disease or no disease. Regression problem is when the output variable is a real value such as dollar or weight. Suppose we are given a basket filled with different kind of fruit. Now the first step is to train the machine with all different fruits one by one like this. If shape of object is rounded, right? If the new data set which is coming having a shape as rounded and has a depression on the top and color is red, then it is labeled as apple. If shape of object is long curving cylinder having green yellow color, then it is labeled as banana, right? So this type of labeling we will do. So we already label the outcome variable, and machine learns the labeling based on the previous historic data, right? And whenever any new data variable will come as an input, machine will try to correlate based on the parameters and predict the output variable which is already labeled in a specific category. So supervised learning has a presence of supervisor, right? Basically, supervised learning is when we teach or train the machine using the data that is already labeled. Now, what is unsupervised learning? Unsupervised learning is the training of machine using information that is neither classified nor labeled, right? It's new to the model, and allowing algorithm to act on the information without guidance. In supervised, we do have teacher, right? We have supervisor to review the data based on historic condition which has already happened, and output is labeled. But unsupervised learning, it's new, it's completely new data set for the machine to go and deep dive the information and classify it accordingly, right? Here the task of machine is to group unsorted information according to similarities, pattern, and differences without any prior training of the data. Unlike supervised learning, no teacher is provided. That means no training will be given to the machine. Therefore, machine is restricted to find the hidden structure is unlabeled data it by itself. For instance, suppose it is given an image having both dogs and cat. We have an image having both dogs and cat which has never seen by our machine model. Thus, machine has no idea about the feature of dogs and cats in the diagram. So we can't categorize it as dogs or cat, right? But it can be categorized them according to their feature like similarity, pattern and differences. That is, we can easily categorize the above picture into two parts. First may contain all pics contain the dogs in them, and the second part where the picture has a cat in them. Here you didn't learn anything before, right? You explore the given data and categorize based on the feature like similarity, pattern, difference and all, right? It allows the model to work on its own to discover the pattern and the information that was previously undetected. Mainly deal with unlabeled data. Unlike the supervised learning, here we don't have labeled data. Unsupervised learning is classified into two categories of algorithms, which is clustering and association. A clustering problem is where you want to discover the inherent grouping in the data, such as grouping customer by purchasing a behavior. Association rule learning problem is where you want to discover the rule that describe large portion of your data, such as people that buy X also tend to buy Y, right? Suppose you go to the supermarket and buy bread, so there is association. If you buy bread, obviously you are going to buy a milk, right? So this is how unsupervised learning algorithms work for data science. These are the basic algorithm in supervised and unsupervised learning which we use. We have already seen logistic regression, linear regression, a priori, decision tree, ANN, SVM, which is support vector machine, PCA, principal component analysis, and k-mean clustering. Let's see the definition of each and understand how this algorithm works. Logistic regression. Logistic regression estimates the probability of an event occurring, such as voted or didn't vote, based on the given dataset of independent variable. Since the outcome is the probability, the dependent variable is bounded between 0 and 1. Linear regression analysis is used to predict the value of variable based on the value of another variable. The variable you want to predict is called dependent variable, and the variable you want to use for prediction other variables value is called independent variable. In linear regression, you have two variables, one is dependent, other one is independent. So independent is something output variable which you want to predict, and independent variable are the variable based on that you are going to produce the output, which is dependent variable, right? It's a dependent variable. Logistic regression estimate the probability of event of occurring, whether it vote or didn't vote, right? But as it calculate the probability, it always the value of logistic regression always lies between 0 and 1. A person or anything will vote for the output or didn't vote for the output based on the given independent variable, right? Third one is a priori algorithm, which refer to an algorithm that is used in mining frequent product data set and relevant association rule, right? So you take a product data set and identify the rule. Generally, the a priori algorithm operates on database containing a huge number of transactions, right? So if you have huge number of transaction database, you can do a priori algorithm on that to identify the associations of data sets or the different frequent data set occurring in the complete data set of transaction. Decision trees are non-parametric supervised learning method which is used for classification and regression. The goal is to create a model that predict the value of output target variable by learning simple decision rule inferred by the data feature, right? So you know the tree diagram, right? We classify data into different data sub data sets and create a different class of data based on feature, right? So we do use decision tree for classification and regression, where any new data input can be predict based on some decision rules, right? SVM or support vector machine is a linear model for classification and regression problem. Here also we do classify or identify a regression value like a numerical problem we can solve. It can solve linear and non-linear problem and work well for many practical problems. The idea of SVM is simple. Algorithm creates a line or a hyperplane with separate data into two classes, and then based on that data is coming on which side of plane or line, we can classify data accordingly, or we can predict the classification of that incoming new data accordingly. Principal component analysis, PCA, is the process of computing principal component and using them to perform a change of basis on the data, sometimes using the first few principal component and ignoring the rest. So in a large data set, we just pick up some few principal components, like few data sets which is critical, which is important in nature, and try to see the behavior of that data in terms of change in other attributes. And then we do analysis, we identify the principal component and its behavior over the change of new data, and accordingly we predict the for outcome for the new data, right? So what we do, we use some data set and ignore rest, because that weightage of the data set which we are using out of the big data set is more as compared to the complete. So whatever analysis we will do, we'll do the few principal component and ignore the rest data. K-mean clustering is a simple unsupervised learning algorithm that is used to solve clustering problem. It follows a simple procedure of classifying a given data set into two number of clusters, right? So whatever data set has been given, you classify that data in different cluster defined by the letter K, which is fixed beforehand. So what you do, you classify a given data set into K number of clusters, which K value of K we decide before executing the algorithm, right? This is unsupervised learning, where we don't have supervision or the labeled data. We go explore the data and classify based on their similarity feature or differences into different clusters. Artificial neural network, ANN, are biologically inspired computer program designed to simulate the way in which the human brain processes information. Artificial neural networks gather their knowledge by detecting the pattern and relationship in the data and learn, or are trained through the experience, not from the programming, right? So will use the piece of code to predict the output. Here our model will work as a human brain, right? So that's why we are using the neural network. Like our neurons works in and send all information to the brain, this model also, if for any data set, it detect the pattern and relationship in the data, learn it over the experience, and predict for any new data set coming in, right? So this is all the basic idea behind the different algorithms which we use in data science: logistic regression, linear regression, a priori algorithm, decision tree, support vector machine, principal component analysis, k-mean clustering, artificial neural network, ANNs, right? Next, data science processes. So if suppose you get a data, you want to perform a data science research on the data, what different processes you follow, right? So we will learn here. So there are different stages in identifying the data science or performing a data science research on the data, right? So here you can see on the right side is the different stage, and left side we have a process diagram. First one, prior knowledge; second, preparation; third, modeling; fourth, application; and then knowledge. So in first phase or first stage, what we do, we understand the business, we understand the data, right? So business understanding is must, right? So as I told you in the skill set of data science part, it is not necessary that you should have programming knowledge. If you have business domain knowledge or other skills, you can participate in your data science journey. If you don't have a technical or programming skill, right, and it feel difficult for you to be a part of data science, it's not necessary that only the technical skill guy can participate in the data science process. The business and other research skilled person also can participate in the data science process, right? So first, once you have the data, you will first understand the business knowledge and the data knowledge, right? You will understand data as well. As you know, the process behind business, what business and in which domain this data comes from, and what are the processes in the business for which the data is getting generated. You see the data, you understand data, how it has come. The second step is to prepare the data for your data science modeling, right? So in preparation, what you do check data thoroughly and try to make the data more appropriate for modeling, right? So you try to remove the duplicates, you try to fill the null values, you see the pattern in the data and try to create a unique pattern to have better understanding on the data. So all the preparation part, right, exploration on the data and preparation, you will do in this phase. Okay, there are different techniques which we are going to learn in detail for preparing data, how we should do and what all things we use to prepare the data. We have some packages available in Python and R programming which we can use to directly get the data and do some massaging on the data, right? Next is building model using algorithm. So what we do here, we build a model, right? So based on the data, the filtered data, we from the raw data we do some massaging and prepare a data for our model, right? So that prepared data we use to create a model by using different algorithm which is suitable for our business use case, right? And if once we have the model, we will partition the data into training and test data set. We will use training data set to train our model. Now once we have trained our model with the training data set, we can use the same model for prediction, right? So we will have some test data set, we'll perform a testing how our model performing, right? So what we will do, we will take a partition of data from the original data set, prepare a training and test data set, we train a model, and then with the test data set we will try to test the performance or evaluate the performance of our model, right? Once our model gives a better performance, we do some performance analysis as well, like accuracy measure. So there are various performance evaluation mechanism which we will use to test the performance of our model. Once our model is ready, tested, giving a good performance, we will deploy that performance in the application, right? Various, either we can give the deployment in a mobile application or any software development team, or we can deploy it as a standalone for giving the prediction and reporting, right? So based on the output of that model, what we will do, we will take the output and apply some knowledge and action to create a better business benefit related applications, right? So this is how the data science process works, and whether you are a programmer or a business SME or a data engineer or a Python engineer, machine learning engineer, deployment executive, you can utilize your knowledge in the data science journey of your organization, right? And these are the right hand side, you can see the various stages in the data science process. So I hope now you have understood how data science process work in any organization. Now as you have understand how data processes work, I want to illustrate you a basic diagram to understand how data engineering works, right? Let's look at this diagram. You can see the first we got a data in unsorted way, an unorganized data, right? Then we have sorted the data, we arranged in a right way, we presented it in a visual way so that we can visualize something out of the data. Once we have the visualization available, we can create some story from that data, right? As we know the story of data, we can apply it in different applications. So this is how our data science process works. So this is very basic idea how we do data engineering and data science for day-to-day business application. I hope this make you more comfortable about understanding how data engineering works. Now let us understand the life cycle of data science. So there are 6 in data science life cycle, and each steps are iterative to previous one, right? So we have discovery, data preparation, model planning, model building, operationalize, and communicate the result to stakeholders. Once we start our data science project, we first discovery about the data from which all sources we can get the information and the data for our project, right? As we got all the data available from the different sources, we have to reach out different departments within organization or outside the organization to get the right data for our project. Once we have the data, we can prepare it with the different techniques available for us. As we have the prepared data in second phase, we can go for the model planning, right? Now the best part is to understand each of these steps are iterative in nature, like it can go back to correct something and again come here for the next step, right? So in model planning, what we do, we plan for our model creation activity based on the data, let me say prepared data available with us, right? Once we have the proper plan in place, who is going to build what algorithm we are going to use and all, we can start building our model, right, with the team. As our model is built, we can make that model operational by implementing it with the software team or as a standalone for creating reports and dashboard or suggestion report, right? And based on that operationalized data report or the model, we have to communicate the outcome of that model to our stakeholder, right? As they want to showcase the application of our project, data science project in business. If you have observed from stage 5 to step 6, there is no iteration back, it's only the forward process, right? Once we operationalize our model, it will communicate to business user, but it cannot come back, right? It will go forward again. If something new is there, new enhancement is there, the team will report it to our data science team, and then they will do discovery, preparation, model planning, model building, and again operationalize this, right? So this is how data science life cycle works in all the projects. Data science teams and roles. I'll start with the most confusing thing for all of the people who is working or wanted to work for the data related profile. Data science and data analytics, right? So both are different. Yes, they do share some common skill, but both are a different profile. Data science skill should have computer science knowledge, machine learning, software development, big data software tool knowledge like Hadoop and Spark, and obviously the algorithm development knowledge, data algorithms. On the other hand, data analytics or data analyst require a data analysis software knowledge, database management system, business intelligence tool skills like Power BI and Microsoft, data visualization tools he should have knowledge to handle like ClickView, D3JS, and Tableau, Power BI. There are many more. And what are the common skill between these two profiles, right? So basic statistical analysis should be applicable to both the roles. Programming knowledge including Java, Python, R, and SQL, data mining techniques, problem solving skill, data storytelling often to non-technical audience, right? So how do you communicate to non-technical audience for the benefit or the story behind data, right? So that skill is required for both the roles, data analyst as well as data science. So I hope this diagrams clears you idea about both role and what are the common skill between these two roles and the differences between these two roles, right? Now let us consider any project, how different team within a data science or different stakeholder within a data science will work to create an outcome of the project, right? So basically in data science team, we should have business analyst, we should have system analyst, we should have middleware experts like who can create a multiple interface between the systems, integration experts, data engineers, data scientist of course, machine learning engineer, and a software developer, project manager, and team manager, right? So these are the roles which is applicable for data science team. and they work together to create any successful project, right? Let's see this diagram where we have presented the process flow, how any project works for implementing data science related technology, right? So I'll start with the raw data. You can see here raw data is being available for data engineer, right, or data analyst or data scientist to work on that data, right? What data analyst will do? Data analyst will create some data mart, insights, dashboards, or visualization report out of that raw data. What data engineer will do? Will process data and do some exploratory analysis or pre-processing or pre-modeling analysis on the data and provide it to data scientist. Rather, data scientist also can work sometime like a data engineer. They can by themselves do all this data preparation activity by themselves, right? Once data is ready, they will prepare a model, train a model, test model, and deploy that model, right? Either they can deploy that model standalone, or they can provide it to a software team for integrating through API with the any application, right? So business analyst and system analyst. So business analyst mostly take the business requirement from the stakeholders, project stakeholder. He identify that what are the business cases which we can implicate on the available raw data, provide those business use cases to system analysis, and system analyst will analyze the requirement with the help of available data in terms of system requirement, and then provide that information to data engineer to work on the project, right, based on the available data in the raw format. So this is how it works, right? Business analyst will take the requirement from all the stakeholder, give it to system analyst. System analyst will provide or just drill down that requirement, business requirement, into system specific requirement. Then system specific requirement will be given to data engineer along with raw data. He will analyze that raw data, prepare it for model creation, and give it to data scientist or researcher. Now data scientist will create that model and check the accuracy of that model, how it is working, test it, train that model, and give it to software team or deploy it as a standalone model. Software engineers or developer, what they do, whatever application they are working on, if it is required to integrate that model with their application, they will use some they will use that model to integrate with the help of middleware team or the integration manager or team, right? Overall process is being managed by data science manager, whether each data science related initiative is getting fulfill the business strategy or the organization strategy or not, right? This is how data science team and different role within the team work to implement any project in organization. So I hope you understand how data science team works to implement any project, right? So this is all about the introduction of data science. So this is all about the data science introduction part. Hope you understand how data science works, what are the processes in data science, what are the team and roles in data science, what is the difference between data analytics and data science skills, what are the common skill between them, correct? How data science lifecycle works, what are the algorithm we use for data science, what is supervised learning, what is unsupervised learning, different tool we use in data science, right? Skills of data scientist, multiple discipline in the data science process or project, right? Type of data analytics we have seen: predictive, prescriptive, diagnostic, and descriptive. Various application and use cases of data science, skills, demand, and all, right? So this is all we have learned as part of our introduction to data science lecture. Thanks. Have a great day ahead. Bye.